Good morning, everyone. We will not do ninth chapter. Adityaman is asking, sir, will we do chapter number 9, which is cut from the syllabus? We will not do ninth chapter. But yes, obviously, one lecture I'll give to ninth chapter also, just to see what is there in that chapter. What are the theorems in that chapter? Because that chapter is linked with some of the questions in 10th. So that's why we need to study that concept also. Okay. For that chapter, just you have to make a note of one page in your notebook, 1 or 2 pages. That's it. That will be only one lecture after this chapter. Okay. Now, exercise 13.5, we were on this exercise. So starting with this question number 6, still question number 5 we have done. A village having a population of 4,000. A village having a population of 4,000 requires 150 liters of water per head per day. Means one person require 150 liters of water per day. Means in one day, one person require 150 liters of water. Okay. Now the population is 4,000. So we can easily calculate that how much water is required by the entire population of the village. Now, what is this? It has a tank measuring 20 meters into 15 meters into 6 meters. So for how many days will the water of this tank last? How many days the tank will get empty if 4,000 population a village has, and they each of the member is requiring of 150 liters of water for one day. So it's right. Water required by, or you can write better, volume of water required by 4,000 write this x1. Wait a second. So volume of water required by the entire population of village, that is, and of village in a day. So in one day, how much volume of water is required? That is 4,000 multiplied by 150 liters. That is 60,000, 6 lakh liters. Now convert it into meter cube, divide by 1000. Meter cube is a bigger unit. I have told you yesterday. 1 meter cube contains, you can write here, 1 meter cube contains 1000 liters. Now volume of tank. Now let us check how much water is there in the tank. So volume of tank, L into B into H, and LBH is given in the question, 20 into 15 into 6. That is 1800 meter cube. Now time, just what it is written, just see in the question. How many days will the water of this tank last? Water of this tank, of the tank, will last for how many days? The volume of the tank is, just right here, volume of tank divide by volume volume of water required per day. So volume of tank is 1800 divided by 600, that is 3 days. So water of the tank will last for 3 days only. Means the tank will get empty after 3 days. Is it clear to you why we have divided this? Because in one day 600 meter cube of water is required by a village. So 1800 meter cube of water will get empty after, this tank will get empty after 3 days, because 600 multiplied by 3 is equal to 1800. So 600 one day, then 600 other day, the 600 one more day, then 1800 meter cube of water will get finished. That's why we have divided. Note it down. Now next question. Question number 7. A go down measures LBH are given. Find the maximum number of wooden crates of this measurement can be stored in the godown. So how many wooden crates you can keep in that godown? If godown has length, breadth, height, this. Godown has dimension this, and the crate has dimension this. So how many crates can come in that godown? Right. Dimensions of godown L, B, and H are 40 meters, 25 meters, 10 meters. Dimensions of wooden crates, that is LBH, 1.5 meter and 1.25 meter. Veer Devendra has written in the chat, sir, volume of godown is 15,000 meter cube. But there is no need to calculate the volume in this way. It will be a wastage of time, according to me. Just write here number of wooden crates that can be stored in the godown is to be calculated by the formula volume of godown divided by volume of crate. So volume of godown is also LBH. This is also LBH. So multiply them. Volume of godown 40 into 25 into 10 upon 1.5 into 1.25 into 0.5. Remove the points. This is removed 10. This is removed 100. This is removed. Godown height is 15 meter. It is 10 meter here in my NCRT, online NCRT. In your book, is it 15? Just check it out. Is the godown height is 15 meter in your book? Koshima is saying, sir, it is 15 here in our book. Yes, it is 15. All are writing. Okay, so I'll solve by 15 with 15 if it is there in your book with 15. Earlier also I have seen this in one of the chapter, that in online book and NCRT site, there is a difference. Okay, I am taking it 15 here. 100 and this is again 10. Now cut them. 15 cancels out. Then after that 25, 5s are 125, 5 8s are, and 5 2s are. So it is 16,000 crates. Don't write crates here because we have written the statement number of wooden crates equals to 16,000. Next question now. See what is mentioned in the question. It is a solid cube of side 12 centimeter. It's cut into 8 cubes of equal volume. Okay. Side of solid cube that is 12 centimeter. And let me calculate first the volume of this solid cube. That is a cube, as it is a cube, so 12 cube 1728 centimeter cube. Now this solid cube is cut into 8 cubes of equal volume. So volume of each new smaller cubes. So what will be the volume of each new smaller cubes? It is written no, 8 cubes of equal volume. So divide the volume of solid cube by 8. So volume of each new smaller cubes will be 1/8 of the volume of the solid cube. Divide it. So it is 216 centimeter cube. We have to find the side of new cube. If the volume of new cube is 216 centimeter cube, then we can put the volume formula. A cube is equals to 216. Let us show, see this here also we have written A. So let us write here A1. Okay, just to represent the sides by different variables. So it is A cube. So it is A1 cube. So what will be the value of A1? Cube root of 216, or this way also you can write raise the cube of 6. So A1, that is the side of new cube is 6 centimeter. Now we have to find the ratio between their surface areas. First of all, they're talking about new cube, or sorry, the solid cube, the bigger cube. Then they're talking about the smaller cube. So we'll keep the surface area of bigger cube in the numerator and surface area of smaller cube in the denominator. So just write ratio of surface areas is equal to surface area of solid cube, means the bigger cube, upon surface area of smaller cube. So formula for surface area is 6a square, and for smaller cube 6a1 square. 6 and 6 cancels out. Here the side was 12 square and here it is 6 square. So 12 into 12 upon 6 into 6. So it is 4 by 1, or we can say 4:1 is the ratio. Clear? If you are not clear with this, why we have divided it by 8 to find the new volume, you can ask. Janvi is asking for the solution of question 7. Wait, I'll show you that. Note it down. I'm just showing the solutions. Those who have not written, they can take screenshot right now and write it down in your notebook. So Yash is asking to explain from here. See what is written here. Also find the ratio of their surface areas. Now surface area of cube is 6a square. Yes, so surface area of that bigger cube upon surface area of smaller cube. Just write like this, and surface area is 6a square. So the side of solid cube we were representing by a, and side of smaller cube we have represented here by a1. So we'll write here a1 square. So 6 and 6 cancels out, and the side of solid cube is 12, and side of the smaller cube is 6, which we have calculated right now. Okay, so just multiply this 12 into 12, 6 into 6, cut them, 4:1 is the ratio. Okay, now the next question, the last of this exercise, then we'll begin with the next exercise. A river 3-meter deep, 40-meter wide is flowing at a rate of 2 km per hour. Okay, depth of river, that will be considered as the height. Width of river, that will be considered as breadth. And rate of flow of river, that is 2 km per hour. Now see this, the question is in meter, so this should be converted into meters, this kilometer, and they are asking us how much water will fall into the sea in a minute. From the river, how much water will fall into the sea in 1 minute. So this hour should also be converted into minutes. So let us convert this first of all. 2 multiplied by 1000 converted into meters upon hour. So 1 hour includes 60 minutes converted into minute. Now cut this. So it is 100 by 3 meter per minute. Now they're asking how much water will fall into the sea in 1 minute. So volume of water fall into the sea in 1 minute is equals to L into B into H, where B and H are clearly visible to you, 30 and 3. But in place of L, we have to write this 100 by 3. And if you are not clear, sir, why in place of length we are writing the speed, then you can ask. I'll clear this doubt. This much meter cube of water will fall into the sea in 1 minute. Is it clear how we have written this length 100 by 3? Okay. Koshima is saying yes. So Koshima will explain to us. Yes, Koshima.
Good morning, sir.
Good morning.
Sir, it is given that in 1 hour, 2 kilometer of water will fall. So we can assume like this, and then we can say that in that in wait sir, 100 meters of water will fall in 3 minutes. So by that we can do it in by 1 minute, and we can take the length as 100 by 3.
Okay, you are correct. Maybe other students have not understood this. So let me tell. Okay, good. See this. I am just trying to make a diagram. Just go into the imagination, everyone. Okay. So this is a very lengthy river. I don't know the length of this river. Okay, so I can't say that what is the length of that river. Okay, so this is a confusing part. So I even don't know the length of this river. This is not a cuboidal box I have made. This is a river where the breadth is, see this, what is the breadth given? 40 meters. So this breadth of this river is, you can say here or here, that is 40. Breadth is 40. And length, we don't know. See, breadth will be specific. We can say approximately it will be specific. And height is also given. The depth of the river is given 3 meters. So this depth is 3 meter. But we can't say about length because river will be very long. So because of that, as we can't talk about length, so they have given us speed. That in 1 hour, it travels a distance of 2 kilometer. Means if river will originate from one point, okay, then in 1 hour, it will make a length of 2 kilometer. We can think like this. And in the same way, in 1 minute, it can make a length of 100 by 3 meters. 100 by 3 means 33.33 meters. You can assume 33 meters. So if river suppose originate from this point, just go into your imagination, think. Suppose river originated from here, from a waterfall. It is coming, suppose it originated from here, and the length began from here, and the river is flowing at a speed of 100 by 3 meter per minute. So in 1 minute, it will make a length of, in 1 minute, it will make a length of 100 by 3 meters. That is 33 meters. Correct? In this way, we can assume length as 100 by 3. And see this, we have not written here 100 by 3 meter per minute. We have written here 100 by 3 meter only. And that 1 minute we have written in this statement. That volume of water that will fall into the sea in 1 minute is, because for 1 minute we know the length, that is 100 by 3 meter. This is the concept used here. That's why we can use in place of length 100 by 3 meter. See, what do you mean by the speed? Speed formula is distance upon time. And if we are specific to the time, that in 1 minute only we want to know the volume of the water that will fall into the sea, then in 1 minute the length will be specific, fixed. Okay, this way. Is it clear? And suppose river originated from here, and it will fall, the water will fall into the sea. So in 1 minute, this much of length of water will fall into the sea. So this is the concept behind this. That's why in place of length we have written this 100 by 3 meter. This type of question is very, very important. Not from 9th point of view, even from 10th examination point of view. There also you will deal with this type of question, or this type of question, yeah, in 10th also, in volume surface area, or in other chapters also. So this is always an important question. Okay. Now this exercise is over. Now let us begin with the next 13.6. And before starting this 13.6, what is the volume of cylinder? Because here we have to use the volume. Volume of cylinder is pi r square h. And maybe in some of the questions we have to use the surface area also. So CSA is 2 pi RH and TSA is 2 pi r h plus r, and CSA plus top bottom is 2 pi r h plus pi r square. So these were the formulas. So question number 1. The circumference of the base of cylindrical vessel. A cylinder. So base is what? A circle. So a circular shape is formed always at the base and at the top of the cylinder. So that's why they write base. Okay. So the circumference of the base means circumference of this circle is given 132 centimeter. Okay. And height is given 25. So how many liters of water it can hold? So it is so simple, right? Circumference of base is 132 centimeter. See, if you want to calculate the volume, how many liters of water means what is the capacity of this cylindrical vessel, or what is the volume of this vessel we have to calculate. So to calculate volume, we need H and R. H is given in the question 25 centimeter and R is not given. And instead of R, they have given us circumference of the circle. Circumference of the circle, we know that is 2 pi R. So with the help of this, we can calculate R. So first step is to calculate R, then we can calculate what is asked in the question. So 2 into 22 by 7 into R is equal to 132. So R is equal to 132 into 7 upon 2 into 22. With 11 we can cut this also, then this, then again this. So R radius is 21 centimeter. So it is 21 centimeter. After this, volume of water vessel can hold is pi r square h. 22 by 7 into r into h. H is 25. With 7 we can cut this. So we can multiply this all. 34650 centimeter cube. And after this, we have to convert into liters also. So converting it into liters, 34650 divide by 1000. So it is 34.650 liters. Note it down. Done. Now the next question. Question number 2. Now time is less. The lecture is going to get over. So we are ending our lecture here. So now it is Thursday, no? So tomorrow also we have a class. So tomorrow we'll complete this exercise 13.6. Only there are 8 questions or 7 questions are left that we'll be able to do tomorrow. Okay, so just here it is completed. Bye. Take care.